Hello and welcome to the stream. This is Python Web Technologies, and this is Season 2, Episode 2 of me doing these live streams. And today, what we're going to do is deploy a web app using a Python package which is called Streamlit. Hi, I'm Peter, and I teach engineering at a community college in the Pacific Northwest. I'm also a blogger, so you can find my blog here at pythonforundergradengineers.com, and I'm also an author. You can pick up my book Problem Solving with Python here on Amazon. If you are following along with the stream, then you could go to this GitHub repo, which is github.com Professor Kazarnoff Stream 2020. And we are in Season 2, Episode 2, and we're going to be looking at Streamlit. So the link to my blog is also in the GitHub repo, and the link to my book, that's also here in the GitHub repo. Before we get started, let's quick talk about the code of conduct. If you're participating in the live stream, commenting, just be aware that we've got a code of conduct. Be friendly and patient, be welcoming, considerate, respectful. Be careful in the words that you choose. Moderate your expectations. I'm not doing this professionally. I'm doing this in my free time, trying to just connect with other people out there during this rough time. And when we disagree, let's try to understand why, and a simple apology can go a long way. If you believe someone's violating the code of conduct, either with their comments or other things related to this stream, you can file a report to this email, info@problemsolvingwithpython.com. Alright, so let's talk about what we are going to do today. So today on the live stream, we are going to deploy a Python web app using this package called Zappa. So Zappa is a Python package that allows you to excuse me, we're not doing Zappa today. I guess that's why we're doing the live stream. No, what I said here was that we're doing Streamlit. Whoops. Okay, so forget all that Zappa stuff. We are going to be deploying an app with Streamlit. Streamlit is a way of deploying Python web apps from simple.py files. And it's especially good for things like dashboards or interactive web apps with data. So here at streamlit.io is the documentation, and we're going to be deploying a Streamlit app following along in my blog post talking about Streamlit. So I'm going to go here to my blog, and we'll type in Streamlit, and it's this post, how to build a Streamlit app in Python. So we talked about how Streamlit is a web app building framework for Python, and it's a way we can turn simple.py files into web apps. And you can do that without using a complicated web framework like Django or Flask. We're going to also be deploying it on Heroku, so you also don't have to spin up your own server like on AWS or on Linode or DigitalOcean. So we'll start off first installing Streamlit, and then we'll run a simple Streamlit app, and then we'll create like a more complicated Streamlit app, and I'll talk about that a little bit more. And we're going to be using this web app called, this plotting library called Bouquet. And then after that, we are going to deploy Streamlit on Heroku. Heroku is a managed service for running web apps, and it's a little bit simpler to deploy a Streamlit app on Heroku than it is to deploy it on a virtual private server like on AWS or on Linode. Alright, so to get started, what we'll do is we'll create a virtual environment, and then we will activate that, and then we'll install Streamlit. Alright, so I've got a terminal open here, and I'm going to cd into the season 02 episode 02 directory, and maybe let's see if we create all these files just right here in this directory. So we'll type python 3-m venv to activate the virtual env module, and then we'll name our virtual environment venv. And this will create a Python 3 virtual environment. In my installation of Python, I'm running Ubuntu 2004. I've got to type Python 3. If I just type python-m venv, then it says command python not found. Alright, so now I've got this venv directory here, and if I type source venv/bin/activate, that will activate the virtual environment. I can tell that it's active because venv is here in front of the prompt. So let's actually just increase the font size here so that you can see a little bit better. I forgot to do that. Okay, so if we do, I guess our virtual environment isn't active anymore, we can't see it, so we need to do a source venv/bin/activate. Alright, now we'll pip, maybe we'll do the python-m pip install Streamlit, and this will install Streamlit into our virtual environment. Streamlit's got a couple dependencies, I guess, so it's got to install a couple more things than just Streamlit by itself. I think it's almost done here. Alright, so now if we clear our terminal and type Python, we should be able to import Streamlit, and that should run without error, and then we should be able to call Streamlit --version --. So double underscore on that version attribute, and we've got the Streamlit version. So if we type exit, open parentheses, close parentheses, that will get us out of the Python REPL or the Python prompt. Alright, so if we now type Streamlit hello, This will welcome you to Streamlit, and we can just leave this blank. And it opens up a web browser, and then we can see a more complex demo, see what Streamlit can do. So let's select a demo. Let's do a plotting demo. So here's like a live plot running. Pretty cool. Let's do one of the other demos. Let's do animation demo. That one's pretty cool too. Alright. So we've seen a couple of Streamlit demos. Now let's create our own just very simple Streamlit app. So I'm going to copy the code here from the blog post, and then we'll paste it into VS Code, and we'll go over some of these lines. So I've got VS Code open here, and I'm in my season 02, episode 02. And actually, when we're in here, I need to go into git ignore, and I got to make sure it ignores that virtual environment. So season 02, episode 02 slash venv slash. So now the venv is grayed out, so it's not going to save that in GitHub. Alright, so let's create a new file, and we'll call this simple streamlit app.py. And I'll make my font a little bigger here. And I'll do Control V for paste. Okay, so let's go through this code real quick. This is just a comment on the top that says what the file name is. And then I've got these triple quotes. In Python, you can create what's called a docstring using triple quotes, and we can have sort of like a multi-line comment. So it just says, this is a simple web app built with Streamlit. We run the app by installing Streamlit with pip, and then we type streamlit run simple streamlit app.py. So then we've got our import line. We import Streamlit as st, so whenever we call st, then we're using the Streamlit library. So st.title sets the title for our web app. That'll be in a big font. Then st.text will show some text on the screen. And then we do this st.number input. This will create like a box that the user will be able to put a number into. And then we set the number that the user enters to the variable n. Then we call streamlit.write, and then we're using an f string here, so we can insert the value of the variable n that goes in these curly braces, and the f before the quotes that denote the string mean this is a Python f string. And then we've also got an st.text input, so I'll make a little text input box, and then type a name in the box below. That's what that input box will say. And then we've got another st.write with another Python f string, and so it'll say hello, and then the value of the variable s, which we've set equal to whatever the user's input is. So let's give this a save, and then I'll open my terminal back up here. Do Control C to cancel. If we type ls now, we can see this simple streamlit app.py. So we'll call streamlit run, and then simple, let's see if autocomplete works. Oh, it does. Simple streamlit app.py. So that opens up a web browser, and I've got an exception. Let's see here. All numerical arguments must be of the same type. Value has float type. Step has int type. Alright, so I think we've got to change the step to 1.0 instead of just 1. Alright, let's go back to our code here. If we do step is equal to 1.0, a float. Now let's go back to the terminal, type Control C to stop. I'm using a little trick in Linux on the terminal. If you push the up arrow, that will give the previously typed command to come up. Alright, so let's run this again. Whoops. Up arrow, run this again. Let's see if it runs without error this time. Awesome. Alright, so we've got our number here, and let's increase here. Cool. And then let's type a name in the box. Let's say hello to Peter. And it says hello Peter. So like, how simple was that? We had very few lines of Python code, and we've got this little app which is running locally. Pretty cool, pretty easy. Okay. So next what we're going to do is create a more complicated web app, one that's got some plotting in it and some user input in it. And we're going to use this Python package that's called Bouquet. Bouquet is a Python package which is used to build plots that are usually displayed in web pages. And a Moore's circle is a circle that's drawn in engineering mechanics that shows the shear and normal stresses within a stress element of a material at various different angles as that stress element is rotated. You don't have to know a whole lot about what a Moore's circle is. Just know we're going to have the user be able to type some stuff in, and then the plot that Bouquet builds is going to be different based on what the user types in. Alright, so I'm going to install Bouquet, and I need to install NumPy as well. So I think I can just do pip install NumPy in my virtual environment. So if I do clear, we'll do python -m pip install NumPy. Oh, it's already satisfied. Cool. Maybe NumPy is needed in Streamlit. Okay, and now we'll install Bouquet, but let's see if we can actually just install Bouquet with pip. So I'm going to type python Bouquet, and here are the Bouquet docs. And here we'll go to installation, optional dependencies. It looks like we can just do pip install Bouquet. Alright, so we'll try that. Go back to my terminal, python -m pip install, and then Bouquet. Gotta make sure I spell it right. And maybe we'll quick make sure that Bouquet was installed successfully. We'll bring up the Python prompt, and then we'll import Bouquet. That works. And then let's call Bouquet dot -- version. Seems like it installs with pip just fine. Okay, so let's go back to our code here. So we need first this little user funcs file, and this is just some of the functions that will do some calculations for our Moore's circle. And then we're also going to have this Streamlit app bouquet.py file. So let's create the user underscore funcs file first. User underscore funcs first. From the blog post. So we'll go back here, and then we'll add a file, call this user underscore funcs.py, and then I'll paste. I'm using VS Code here. This is a really awesome code editor. It's free, open source, works on Mac, Linux, and Windows. Starts real quick, pretty powerful, and you can use it to edit Python code or other types of code. Alright, so let's talk about this code here. So we've got a comment with the file name, and then a docstring that has a description. These are just some user-defined functions that we'll need in our Streamlit app. We import numpy as np. np is the typical name that numpy is imported with. Then we've got this morec function, and it accepts 3 arguments: a shear in x, a stress in x, a stress in y, and a shear. So what this does is it calculates the center of the Moore's circle and the radius of the Moore's circle, and then returns both of those two values. And this is a calculation that you could make in engineering mechanics in order to find the center and the radius of the Moore's circle. I'm not going to go a whole lot into it, but just know if you put in these 3 inputs and then apply these mathematical functions, that you'll get the center and the radius of the circle that we're going to draw with bouquet. Then we've got this C-array function. So the purpose of this is to have numpy arrays of x and y points that build the circle, because we need those x and y points in order for bouquet to build that circle. So we're just making like a pretty simple parametric function where we've got this array t, which has a number of different, I guess I'd say, angles in it. And then these values of x and y are created for the points around the Mars circle. And note that we add the plus c here because the center of the circle is not necessarily at the origin for a Morse circle. And then we've got this x underscore y function. This builds an array to describe the line that cuts through the Moore's circle to denote the input of the shear x, stress x, stress y, and shear, and it returns 2 arrays. The arrays are pretty small. Each one of them only has 2 values in it, an x and a y, and an x and a y. Okay, so we need another py file, and this is going to be our Streamlit file. So I'm going to go back to the blog post, and so that I don't spell this wrong, I'm going to copy the file name, streamlit app bouquet.py. Alright, we'll go here, streamlit underscore app underscore bouquet.py, and back to the blog post, and let's copy all the code here from the blog post. So back to VS Code, and we'll do a paste. Alright, so let's talk about this code a little bit. So the file is called streamlit.bouquet.py. We put that in a comment at the top. And then our doc string gives us just a little description of what's in the file. Then the Python packages that we're going to use are NumPy, Streamlit, Bouquet, and then we're also importing our user functions. So from user funcs, that'll come out from this userfuncs.py file, and we're importing the more_c function, the cray function, and the x_y function. Those were the functions that are here in the userfuncs file. Alright, so we'll give it a title, st.title, and then we'll call it more circle app. A tricky little thing, notice how we've got double quotes to denote the string, and then we can have a single quote to pluralize, or actually this is possessive, right, of more circle. Okay, now we'll make a number input. The user can put in the stress x, a number input, the user can put in the stress y, and then a number input for the shear. And note that here we're doing st.sidebar.numberInput. So this will put like that number input in a little sidebar on the left-hand side of our web page, and I think that'll look pretty good. Then we'll run the more_c function to find the center and the radius of the circle. Remember, there are two output values there. Then we'll run the cray function and input the center and the radius of the circle to get the x and y points that make up the circle. And then we'll build the arrays that plot the line through the circle. We'll feed in the stress x, stress y, and the shear. That comes from what the user entered above, and it'll create these x and y arrays. Then we will output some values. So here I did st.sidebar.markdown instead of like st.text. That'll make the text in markdown format. And then we've got our max stress, and this is an f string, and we put in the value for the max stress, which is the value of the center of the circle plus the radius. And then the value for the min stress will get printed out, and that is the center of the circle minus the radius, and then the max shear. And I'm just rounding here because these will be floats and we don't want to output too many values. Okay, so next we are creating a figure, and this is a bouquet figure. So up here from bouquet.plotting we imported a figure. So that's what we're calling right here, is this figure. And we've got a title, an x-axis label, a y-axis label. Got to do this aspect match is equal to true so that we get a circle and not an oval. And then we specify some tools that we want on our bouquet plot. So all of these arguments, these are specific to bouquet figures. Then we gotta stick something on that figure. So we draw the circle, and we do that with p.line, and then we feed in the two arrays, the x and y arrays that draw the circle. And then next we draw the line through the circle using the big X array, big Y array. Those are the points that'll draw a line through the circle. And then we do a p dot x-axis fixed location is equal to 0, p dot y-axis fixed location is equal to 0. The reason that we do that is that if the user enters in some new numbers, we don't want like suddenly the plot like to jump all over the screen. And so if we fix those y-axis locations, then we'll always see the x and y axes crossing 0, rather than kind of like being above and below where our circle is. And usually that's the way that more circles are plotted. And now at the end here, this is kind of like the magic. So we call st.bokehchart, and then we feed in our figure object here, p, and that's it. Like, that builds this web page with a bokeh chart. And Streamlit has been built with the capability to display bokeh plots just built in. So this isn't like very many lines of code to have a fairly like complicated web app that calculates something in engineering mechanics. So let's see if this works. We'll run it on the command line. Alright, I'll do a copy. Alright, and let me get my command line here. So we'll call Streamlit run, and then I'll paste the file name in. So I'm going to decrease the size a little bit here so that we can see our sidebar. There's our sidebar. See how much bigger I can get it and still kind of get it in screen there. Okay. So we've got our default values here. Let's see what happens if we decrease our stress in x. So see how the center of the circle is getting closer to the x-axis? How about if we change our stress in y? Well, that makes our circle a little bit smaller. And then note how we've got these max stress, min stress, and max shear values. Those are auto-calculated each time we change the plot. And we've got our neat little like bokeh tools that we can drag the plot around with. We can zoom in, we can zoom out, we can reset, and we can even do a save, like download this plot that we've built. That is like totally cool. Simple little Streamlit app that actually does something that's kind of complicated in engineering mechanics. Alright, so this is great that it's running locally, but what would be better is if we could share this with other people, and it would be better if this could maybe be on a public website, and then other people could use our Streamlit app. So in order to do this, we're going to deploy the web app on Heroku. So Heroku is a cloud platform for deploying web applications on the internet without having to create your own virtual private server. So if you're going to deploy one of these Streamlit apps on Heroku, first you need to have a Heroku account. I already have a Heroku account, so I don't need to create one. And then you also, well, you don't have to have it, but I find it a lot easier if you have the Heroku CLI, the Heroku command line interface. And I've already got the Heroku command line interface installed here on my version of Ubuntu 20.04, but you can use these commands to get it, or you can also do Heroku CLI install and install it as a snap package. So on Mac OS you can use brew to install it, and you can install it as a snap package on Ubuntu. So for me, if I now type Heroku -- version, it'll give me the Heroku CLI version, which is installed here. Now, last time I did a live stream, I had a trouble deploying a web app on Heroku without having a github.com repo for that. So I think what I'm going to do is show you the code up in a GitHub repo, and then I'm going to clone that down locally. So let's cd here, and let's go to my GitHub profile. Whoops. github.com/Professor Kazarnoff. Go to repositories. Let's work for Streamlit. Oh, so this is just the simple Streamlit app. Let's see if we look for a more circle. Interesting. Okay. So maybe I'll create a new GitHub repo, because there's a lot of other stuff in this repo. So I'm going to click Add, New Repo. We'll call this Moore's Circle Streamlit, and a web app, let's say built with Python and Streamlit of a Moore's circle. I'll initialize, we'll add the Python git ignore file, and let's make this GNU, and we'll create that repo. Okay, so I'll copy this repo, and then this is Moore's Circle Streamlit. Excuse me. So back to my terminal, we'll make a directory Moore's Circle Streamlit, and we'll cd into Moore's Circle Streamlit. Then we'll type git init, and we'll create a new git repository. Then we'll type git remote add origin, and then we'll paste the GitHub SSH path here, and we'll call git pull origin master, and now I've got to copy over the code that I had before. So let's see if we type code dot. Alright, so we get a new VS Code window. Great. Alright, so let's go back to our other VS Code window, which is this one. And let's copy our userfuncs.py file. And userfuncs.py. Paste that in. Save. Let's create another file. Streamlit at bouquet.py. So our other file is Streamlit at bouquet.py. And we'll copy all this. Whoops. Save. And in the git ignore, I want to make sure we got v and v, if we put one in there, and that we have a .vs code, ignore all that too. Okay. So I think at least for right now, I'm not gonna worry about that other code, and we're gonna work with this code because it's in its own GitHub repo. So let's just make sure that this runs. If we type streamlit run, and then what was this file called? More? No. Need to do ls. Streamlit app. Okay. Streamlit run. Streamlit app bouquet.py. Let's just make sure it works. That looks okay. That looks okay. That looks okay. Make sure we can pan around. Cool. Let's zoom in and out. Nice. I'll refresh it. Great. Okay, working locally just like it did before. Alright, so we've got to have a couple of files here for Heroku to be able to run our Streamlit app. One of them is a requirements.txt file. So here in our terminal, we'll type pip freeze, and then we'll pipe that to requirements.txt. And now you can see that we've got this requirements.txt file. Alright, so we need two more files for Heroku to run. We need a proc file, and we need a setup.sh file. So the proc file's got to start with a capital P, and no file extension, and then we'll call web, and then it'll run bash on this setup.sh script that we're also going to have to create, and then it does this Streamlit run Streamlit app bouquet. So it sort of runs these two commands kind of at the command line in Heroku in order to deploy our app. So I'll copy this and go back here. We'll create a proc file and we'll paste in. We'll give that a save. And then we need this setup.sh file. And in this setup.sh, this is the stuff from the Streamlit app that is needed on Heroku in order to get it working. So last week on my stream, we also had a runtime file. So let's see what happens if we also include that. So runtime.txt, and we want Python dash 3.7.8. We'll save that. Alright. Let's commit all of these files. We've got our proc file, our requirements.txt, runtime.txt, setup.h, and then our Streamlit files, the user funcs.py supporting file, and then the Streamlit app bouquet.py file. So we'll call git add. Let me make sure they're all saved first, I guess. Make sure runtime saved, setup saved, proc file saved, requirements saved, Streamlit app bouquet saved, user funcs.py saved. Okay. Back here to our terminal, we'll do git add dot to add all the files, git commit dash m, and so we'll say Python files and Heroku files to run the Streamlit app, and then we'll do git push origin master, push those up to GitHub. Alright, so now that it's pushed up to GitHub, now we need to push it up to Heroku. So we call the Heroku login command and log in the Heroku CLI, then Heroku create and git push Heroku master, and then we can call Heroku open in order to open up that link in a web browser. So I'll type Heroku login and press any key to open up a browser, and that's opening up a new web browser. And while I log into the Heroku CLI, I'm just going to put up the private screen. Okay, so the private screen should be up. And just when I do login things with usernames, passwords, I like to make sure that that private screen is actually up. So we'll log in, and now I'm logged in, so I'm gonna go back to the main page here. And it says that I'm logged in. Okay. Sorry that took a little bit. I just want to make sure that I was logged in the private screen, that wasn't all shared publicly. Okay. So I'm logged in. So next we'll call Heroku create. And it's created this Heroku app. It's called Glacial Escampment. And now we'll call git push Heroku master. And this should deploy our web app up on Heroku. So it looks like it detected a Python app. And now it's installing Python 3.7.8, and now it's installing our requirements.txt listed requirements. So that was Streamlit, Bokeh, and NumPy. But those packages, they also have dependencies. So it's got to install all of the dependencies of Streamlit and Bokeh and NumPy as well. So that'll take a little bit. Alright, so it looks like the installation of the Python packages is just about done. So after that, it should run that sh.sh script. So let's see if it gives us any output about running that bash script. So it read the proc file, and it says it's doing some compressing. Now it says it's doing some launching. And hopefully it's gonna successfully launch here. Once this is done, we'll call this Heroku ps scale web is equal to 1 command. So let's call that. So it is running, and if we type Heroku open, this should open up our web app. Yeah, awesome. Alright, so this is like really a public URL. We've also got HTTPS security on it, which is pretty awesome. And anybody could go to this URL and then be able to play with the Moore's Circle app. So let's like make this real small. Let's make this one, I don't know, real big. We can change the shear. We could even type something in here. Let's make sure the bokeh tools work. So we can pan. Let's zoom in and out. Oh man, is this awesome. Do that. Let's see what happens if we do the save. I don't know if this one is going to work. So let's open up that plot. Oh my goodness, this is so awesome. Even like saves the plot locally. Whew, that is pretty darn cool. So not too much code to create a pretty nice looking Python web app that does something fairly complicated in engineering mechanics using Python, Streamlit, and Heroku. That is pretty darn cool. Alright, so that's running, and it looks like everything like totally works. So I just want to shut it down. So if I do Heroku open again, then I get my Streamlit app. Okay. And to get rid of it, Heroku apps. So it says I've got that. And Heroku, maybe apps -- help. Does that work? So we want Heroku apps destroy, and then the name of the app. And ours was this glacial escapement. So I'm going to copy that. So I'll do Heroku apps destroy. Oops, destroy. And then we'll list the app name. And then proceed type glacial escarpment 76640. So now if we type Heroku apps, it says you have no apps. So I just want to make sure everything in the GitHub repo is saved. So I'll do another git add dot git commit -m final commit of the night after the end of the stream. Then we'll type git push origin master. Says everything is all up to date. Alright. So this concludes the stream for today, where we deployed a Python web app on Heroku using Streamlit. I really enjoyed like getting this up locally and then also getting this up online so that anyone can see. So thank you very much for watching, and I hope that you will join into the live stream next week. I will see y'all later.